In this example, you're asked to solve the equation tangent squared of 2 theta equals 3 if theta is between 0 and 360 degrees. Notice that this equation has the form u squared equals a number. So just it's some expression squared equals a number. There's no u to the first term. These are best solved by taking the square root of both sides. It's called the square root property. And remembering that positive or negative square root of whatever this number is would lead to a solution, because when you square the negative root, you still get a positive. Okay, so I've written it in kind of ugly terms there, but so if you go back to the original equation here and square root both sides, and don't forget to slip in that plus or minus, then we have tangent to the first power of 2 theta equals plus or minus the square root of 3. Oops, tangent, I said tangent to the first power and I wrote tangent squared. Sorry about that. There we go. Now, once you get the trig function by itself, it's time to look at the unit circle. Remember that tangent is the ratio y over x. So we're looking for when is the ratio y over x equal to the square root of 3. Okay, so going around the unit circle. Here, the ratio y over x would be 0 over 1. That's 0. Here, any of these coordinates where they're both over 2, those 2's would cancel. If you wrote 1/2 over, let me actually write it out to show you. Taking this coordinate, if you take 1/2 over square root of 3 over 2, the first thing that you would do to simplify that is multiply numerator and denominator by 2, and you end up with just 1 over the square root of 3. So that's going to happen every single time where these coordinates are both over 2. So you can look at just the numerators when the denominators are the same. So here the ratio is square root of 2 over square root of 2, so tangent is 1. Here the ratio is square root of 3 over 1, so positive square root of 3. That's one of those values that we're looking for. Positive square root of 3 here. It's going to happen over here. Again, you have square root of 3 over negative 1 when those halves cancel. So that'd be negative square root of 3. And I'm going to circle that one in blue. Negative square root of 3 there. Down here, the ratio would be negative square root of 3 over negative 1, so positive square root of 3. And I'm going to circle that one in red here, because both of these gave us the solution positive square root of 3. And then the one that I wrote in blue there gave us the solution negative square root of 3. And notice that you're going to get that solution again right here. Y over x would be negative square root of 3 over 1, so negative square root of 3. Okay, so those are the angles that are going to lead us to solutions. Also notice that, remember that tangent has a period of pi. And if you start at pi over 3 and you do half of a rotation, pi radians, or I guess this problem is giving us the inequality in degrees, so we can talk in degrees. 60 degrees, add 180, that's the period for pi. 60 plus 180 would be 240. And if you keep adding 180 degrees, you're going to hit these two solutions over and over. So the solution set that I'm circling in red there could be written as 2 theta, and I'm writing 2 theta just because that's what's inside the tangent function in this problem, is equal to, oops, I keep wanting to do radians, 60 degrees plus 180n. That'll generate, starting with the solution at 60, and then add a 180, it'll give us 240, and then you could go on forever, finding more and more solutions. Similarly, in blue here, I wrote on top of it, but it says 120 degrees there. So I'm going to write 2 theta equals 120 degrees plus 180n. Notice that if you start at 120 and add 180, you get 300, and you hit this solution. And then you could keep adding 180 degrees and cycling between these two positions and generating solutions. Okay, so we've isolated the trig function, used the unit circle to figure out which angles we want to look at, and set the argument, what's inside the trig function, equal to those expressions. Now I skipped over this, but the reason I added the 180 in is to make sure we find all the solutions in this interval. And you should do that whenever you have more than just theta inside your trig function. and get a new page to finish this up. But so that first equation that I wrote in red said 2 theta equals 60 degrees plus 180 n. And then we also had 2 theta equals 120 degrees plus 180 n. We want to solve for theta, and we want to find all the solutions where theta is between 0 and 360 degrees. So we're going to write the solution set down here. So starting with this equation on the left, if I divide everything by 2, I get theta equals 30 degrees plus 90 degrees n. In blue, if I divide everything by 2, I have theta equals 60 degrees plus 90 degrees times n. And we're going to use those two equations to generate the solutions. Starting with if n is 0. If n is 0, then in this equation, theta is just equal to 30 degrees, plus 0 here. So there's the first of our solutions. Over here, if n equals 0, theta equals 60 degrees plus 0. So 60 degrees is another solution. Now let's let n equal 1. So over here, theta equals 30 degrees plus 90 times 1. So 30 plus 90, 120 degrees. Over here, if n equals 1, theta equals 60 degrees plus 90 times 1, so 150 degrees. Okay, we're still less than 360, so we should keep going. Let's try n equals 2 and see if that gives us a solution between 0 and 360 degrees. So here you'd have 30 degrees plus 90 times 2. So that's 30 plus 180 gives us 210. And that's still in the interval between 0 and 360, so that's another solution. If n equals 2 over here, theta equals 60 degrees plus 90 times 2. So that's 60 plus 180, and that's 240, which is still less than 360, so we can keep going. Unfortunately, I think we're going to run into 360 pretty soon here. But if n equals 3 in this equation, then theta, I'm going to squeeze it in here, is 30 degrees plus 90 times 3. So that's 30 plus 270. I really am running out of room here. So that's 300 degrees. Okay, still less than 360, so we should keep going. With this equation, if n equals 3, theta is 60 plus 90 times 3. We just saw that's 270. So when you add 60, that's 330. And now we're getting awfully close to 360 degrees. That is, this is supposed to be a curly bracket, that is going to be the last solution. But just to convince you, if we let n equal 4, that would be the next value of n, because we just did n equals 3. If n equals 4, this is 360 degrees plus 30. So that's certainly more than 360. Same story over here. 90 times 4, that's 360 plus 60. That's definitely more than 360. So this long list over here is our complete solution set.